Hey everyone, we're going to do a quick review of the product rule. So the product rule states when multiplying exponential expressions with the same base, we add the exponents. So our keywords here are when we're multiplying the expressions with the same base. They must have the same base, and we're going to add the exponents. So for example, if we have 3 squared times 3 to the 5th, we notice that their bases are the same. We could see that we're also multiplying the expressions. That means we can add the exponents. So it will be 3 to the 2 plus 5, which is 3 to the 7th. Yesterday we did this the long way. We expanded 3 squared as 3 times 3. We expanded 3 to the 5th as 3 times 3 times 3 times 3 times 3. And then we counted the number of 3's that are being multiplied, which is 7. That's the long way. You no longer need to do that. You can apply the product rule. However, if you forget the rule, when in doubt, just expand it out. Let's do another example. 15 to the 4th times 15 to the 7th. We see that we're multiplying. The second part is, are our bases the same? Yes, they are. They're both 15. That means we can add the exponents, and we have 15 to the 11th. Now, let's take another example and change it up a bit. 4 squared times 5 to the 3rd. Let's ask ourselves those questions. Are we multiplying? Yes. Are our bases the same? No, they're not. We can't do anything with this. So this is done. It cannot be simplified. Let's do another one. 2 to the 3rd times 2 squared times 2. Are we multiplying? Yes. Are our bases the same? Yes, they're all 2. That means we can add all of the exponents. 3 plus 2 plus 1. Yes, there is a 1 at that last 2. Any number that does not have an exponent has an invisible 1 at the top. We have to make sure we include that. So it becomes 2 to the 6th. We can also do this with variables. So x to the 4th times x to the 7th has the same thing as number 2. So we can see this. We see that we're multiplying. Are our bases the same? Yes, it's x, which represents a number. We have x to the 4 plus 7, which is x to the 11th. It has to be the same variable. For example, if I had x to the 2nd times y to the 3rd, we can't simplify this because their bases are not the same. Right? One is x, the other is y, and that does not work. You could also have negative exponents. So let's say x to the negative 5th times x to the negative 3rd. We see that we're multiplying, and our bases are the same. Since our bases are the same, we can add the exponents, and we have x equals, we have it equals x to the negative 8. Right? We're still applying our rules, and we know that when we're adding a negative to a negative, it becomes a negative. That's pretty much it. I'm going to show you one more tricky example. So if we have a 2x to the 4th times x to the 3rd, we can actually simplify this further. We know that there's an imaginary 1 in front of that second term. And we know that we're going to multiply both of these. So really what we could do is we can actually break this apart. And we can use the commutative property to move things around. 2 times 1 is 2. x to the 4th times x to the 3rd is x to the 7th. This is new. We have not done this yet, but I wanted to show you just as we are practicing further. That's it for today, and that's it. Have a good one.